Welcome back for another lesson. Today we are going to be covering surd equations. You would have touched on surd equations in grade 10. In grade 11 you start dealing it more in a quadratic form. 3 examples for the linear example, then we're going to move on to quadratic, and then we're going to mix it up a bit with some K-method substitution and quadratic equations in surd equations. 3 simple ways and we'll build it up. Let's get started. So the expression above is a simple linear surd equation, which you would have encountered in grade 10. And if we had to try and solve this expression, to solve any surd equation usually involves 4 simple steps. To isolate the surd, to square both sides, solve for x as if it was a normal equation, and then number 4, check your answer. You could be completely wrong, so make sure you do that right at the end. Solving this expression, you'd have the cube root of x plus 4 equals 3. Now, a lot of people get a kind of negative block when you start dealing with root signs and the cube root and the square root and the nth root when people see this. So a simple and a more intuitive way of writing it is just x plus 4 raised to the power a third equals 3. If that allows you to understand the expression a lot easier, write it in that form, so that you don't kind of get bogged down by always seeing the root sign. Step 1 would be to isolate the surd, which is what we're doing on this side by keeping it on the left-hand side of the equation. Step 2 would be either to square or cube this entire expression so that we remove this 1 over 3 exponent. So that would be taking this expression and writing it as, raised to the power third equals raised to the power third. Oh, colors are not nice. And you have this expression on the inside, x plus 4 raised to the power third. And what was the fundamentals on exponents, or the law of exponents that Michael taught you guys? 1 power raised to another power is multiplication. So it would be 1 over 3 times 3 over 1. Cancel, so you just have it as 1, which would be step 1 and step 2. Isolating the surd, and 2, trying to get x by itself. So now you've got x plus 4 equals 3 cubed is 27. And now solving for x, which would be step 3, as if it was a normal equation, x is equal to 23. And does that actually make any sense in this expression? So substituting x back into our original result, 23 plus 4 gives you 27. The cube root of 27 is 3. 3 minus 3 gives you 0. Step 4. Check that the answer is correct. So, you would have encountered this in your grade 10 series of work, but now let's take it up a level and get example number 2. Is a similar fashion to the linear example we did before, but now we've included another x term, which will change the expression into a more quadratic term once we work it out. So let's get started. Step number 1 is to isolate the surd, which will be cube root, square root of 3x plus 10 equals x. Now, if you want to do it so that you can see it better, let's write it as 3x plus 10 raised to the power half equals x. Now, if we wanted to raise this entire expression by squaring both sides, we would have the square of both sides. X on the right hand side and 3x plus 10 raised to the power half, which simplified out, which would be 3x plus 10 equals x squared. So we've done step number 1 is to isolate the surd, which was this part. Step number 2 would be to square or cube both sides, which is what we did in this line over here. Step number 3 would now be to manage this equation as if it was a normal equation. So we've reached this point, and now we can get this in our standard form, which would be, for a quadratic equation, ax squared plus bx plus c, or minus c. Now, you could take x squared to the left-hand side, but ideally you wouldn't want your a term to be negative, because it just makes it a lot easier to simplify it if your a term is positive. So we're going to take everything on the left-hand side across and have it as 0 equals x squared minus 3x minus 10 equals, no, as that. And if it makes you a lot easier or more comfortable to have your entire quadratic expression on the left-hand side and your 0 on the right-hand side, which is usually the way you write it, we can always express it in that way to make you feel more comfortable. And we'd have it written as x squared minus 3x minus 10 equals 0. So you've got it in a form that's much more comfortable for you to work with, and now we can factorize this and get our actual solution to this expression, which would be x equals 0. And what two factors can I use to multiply together that will give me 10, which would be 1 and 10, 5 and 2, but would also give me a resultant of 3, or minus 3 in my b term over here. Just highlight that here. Well, I know that the result needs to probably include a 5 and a 2, because that added or minus together will give me 3. Now, my sign selection, I would want this to be minus, and I would want this to be plus. So what are my critical values? Therefore, critical values are x equal to 5 and or x equal to minus 2. So now we've done step 1, step 2, step 3 of solving a surd equation, and we've got our critical values. Step 4 would be to check our answers. So choosing the lesser of the two evils, let's start with x equal to 5. Substituting that into our original equation, you've got the square root of 3, 5, plus 10, minus 5. It must be equal to the right-hand side, which is equal to 0. So 3 times 5, 15 plus 10, 25. The square root of 25 minus 5 equals 0. Because 5 minus 5 equals 0, which therefore equals our right-hand side, which is great. So we found a valid solution for one of our critical values. But that doesn't mean that both critical values are correct. I'll show you once we substitute in x equal to minus 2. You've got 3 times minus 2 plus 10 minus 2 equals the right-hand side, which should be equal to 0. Working this out and simplifying it, you're going to actually get square root of 4 plus 2 equals the right-hand side. But that clearly doesn't work out, because 2 plus 2 is going to give you 4. 4 does not equal to the right-hand side. Therefore, the solution of x equal to minus 2 is not applicable and not a valid solution. So in surd equations, always make sure in the fourth step that you check your answer. And this also changes after squaring both sides. That changes the nature of your not applicable solution. So example number 3 combines everything that you've learned in the last 2 lessons, which is dealing with surd equation, which involves the 4 steps, which are isolating the surd, squaring or cubing both sides, working with x as a normal equation, and then last but not least, checking your answer. And This example also includes the K method for substitution, so you can simplify your expressions before you start working with them. So let's start on example number 3. Looking at this expression, what you see is common here. 2, 20, 1 and 2, no, those are all wrong. The simple and common expressions that you could use here is 2 square root x plus 1. So using the K method, like I showed you, K is equal to 2 root x plus 1. Substituting K back into this, you're going to have an expression that looks something like K plus 1 is equal to 20 over K. Because of the fact that you've got K, draw this in another color, K in the denominator, you know that you don't want to be dividing by 0. Therefore, K cannot be equal to 0, and because of your substitution that you did here, this expression 2 root x plus 1 can not be equal to 0. And that also means that if you had to do all of those things, x cannot be equal to minus 1. So you've already ruled out that a possible solution for that is not possible. Now, taking this expression, and you'd want to simplify it out even further, you'd want to multiply through everything by k, because you'd want to remove it or bring it to the numerator. So you say, multiplying everything through by k, you'd have, take this in a different color, you would have k multiplied by k plus 1 multiplied by k equals 20 multiplied by k over k. Now the important thing to note here that you're doing is that you make sure that you rule or eliminate the possible solution of k equal to 0. So further on, when you simplify it and you get critical values, if you didn't take the time to say that k does not equal to 0 and x should not be equal to 1, you could get a critical value that is 0, but it's because you've eliminated it in this multiplication through. So by having it as no solution, you've already taken into account that k is in the numerator. So be very mindful when you do that, because a lot of people multiply through and they just forget to eliminate critical values. Because obviously if you get k as a possible solution equal to 0, that's impossible. So simplifying this even further, you've got k squared plus k equals plus 20. This looks like a standard form for a quadratic equation. K squared plus k minus 20 equals 0. So you've got it in the standard form for a quadratic equation, which is ax squared plus bx plus c equals 0. And you've got the tools necessary to solve a normal standard quadratic. So let's factorize it. So you've got k equals 0. So which two terms multiplied together would give me 20, and the addition or subtraction would also give me a resultant of 1k. So I could use 20 and 1, I could use 5 and 4, I could use 10 and 2. Of those 2, 3, 4 and 5 would be the most likely solution. So let's write 5 and 4. And knowing that this term over here is positive, you would want k plus 5, and you know that this term, your c term, is negative, you'd want this to be negative. So what your critical values result in? K must therefore be equal to minus 5, or k must be equal to 4. But because we're dealing with surd equations and we've now found our result, we need to check the answer and substitute it back in to the original substitution that we did for this expression. So if we had to take this as 1, we have to take this as 2. So taking result 1 and substituting it back into this equation, you're going to have minus 5 is equal to 2 root x plus 1. Right? And you now want to isolate x so you can find a viable solution. So you're going to have minus 5 over 2 is equal to square root of x plus 1. Square both sides, you're going to have minus 5 over 2 squared equals the root of x plus 1 squared, which would give you, multiplying that through, you're going to have 25 over 4 is equal to x plus 1. So if I had to take result number 1 for k equal to minus 5 and I had to substitute it into this expression for k, and I had to try and simplify it out, and I get a result of x equal to 5.25. You can obviously see the way that I worked it out, because now you're trying to solve for the x value that satisfies this y value. But if you had to try and do it graphically, it would actually show that this result is not applicable, because if I had to, for k equal to 2 cube root x plus 1, and I had to make a function around that, so I had to say the function of x is equal to 2 cube root x plus 1, and I had to try and draw that graphically, it would look something like to cross at minus 1, and it would go something like that. And it would cross the y-axis at 2, f of x, that is x. That's how the graph would look. So for example, if I had to substitute in minus 1 here, minus 1 plus 1 would give me 0, which would make f of minus 1 equal to 0. So that would satisfy that condition. The same as if I had to make y equal to 0, you'd have 2 root x plus 1. Let's take this away. But if I had to now substitute in this value for x of 5.25, f of 5.25 would not satisfy the equality that it is minus 5, because you cannot have, for this function of 2 root x plus 1, you cannot have anything that is negative here, because this expression cannot give you a negative number. So therefore, you can already see that this result of minus 5 is not applicable and not a valid solution. Just by looking at that graph already, you know that it can't cross the negative axis. And you know that it can't be minus 5. It is impossible for it to have a value of, a y value of minus 5. So it's not a valid solution. So now if we had to take result 2, which is here k equal to 4, and we had to substitute it back into this expression, you'd have 4 is equal to 2 root x plus 1. And simplifying this out further, 2 is equal to root x plus 1, squaring both sides. Squaring both sides, you'd have 4 is equal to x plus 1, which would mean that x needs to be equal to 3. And that is a valid solution, because if you have to now draw that same f of x graph, f of x is equal to 2 root x plus 1, which will cross at minus 1 and at 2, you'd have to draw it. If I had to make x equal to 3, my y value here for f of x, substitute 3 into there, 3 plus 4 gives me 4. The square root of 4 is 2, 2 times 2 is 4, so you know that this would cross at 4, which is where k was equal to 4. So that's a third example on surd equations, which covered all of the fundamentals that you learned in today's lesson, which is how to solve surd equations, using the substitution method or K method from the previous lesson, and also by hook and by crook, finding non-applicable solutions that you have in surd equations, which can throw you off. So make sure that you remember the 4 steps. 1, isolate the surd. 2, square or cube root both sides. Then work with x or with k as if it was a normal equation. And last but not least, I cannot stress this enough, check your solutions and your answers, because sometimes you can have solutions that do not exist.